GAC Algebra 3, hope you're having a great night tonight. Man, I hope right now you're either trying to get some studying done for some math, or maybe you're just getting home from lacrosse or wherever you're coming from. But wanted to touch base with you. I apologize, it's starting a little bit later, but I do want to touch base with you. If you could give me a couple of minutes, what I'm going to do is, and if you're watching this to where it's not live, fast forward for a couple minutes, and we'll get started here in a second. My Wacom tablet, something's wrong with it, so I'm trying to get a little creative on this. So if you could just give me a little bit of time, we're going to travel just a little bit, and we'll go into the office over here, and then go from there. So again, if you can hold on for just a second, what you can do is you can look through your review, and if you do have any questions, please feel free to message me. All right, message me, give me those messages there. We could go from there. So try to be a little creative on this. Give me a little bit of time. We'll rock and roll from there. All right, I'm going to pull this up. Hoping this is going to. Hold on just a second. I'll be right with y'all. Okay, so if there's issues, by the way, I'm using a whole different Mac. We had kind of an issue today. If there are more issues, please let me know. Please text me if for some reason it's choppy or anything along those lines, and hopefully we'll do the best job we can. Please be patient with me, because today what we're going to do is I'm literally going to do each of these by hand. This could be very entertaining. So if you want to see some great handwriting, then stay tuned. It's going to be good fun, I think, today. But I'm doing it the best I can for y'all, and then we'll go from there. One of the things to remember that I constantly said is regarding end behavior. We talked about end behavior in terms of the fact that if we had, let's say, x squared, right? And we had, let's get one that's not there. We said that end behavior that would go rise to the left and to the right. There's that one, right? There's also one that kind of falls to the left and then also falls to the right. We'll take a look at that one. And then finally we had one where it rises to the right and it also falls to the left, and then vice versa, where it rises left and then also falls to the right. Now, the reason why I'm doing that, hopefully, is to help you to identify which is which. Remember that in this situation, if it is even, right? So let's give an example. Let's say that this was x squared, right? And it was positive. That means that we would then rise to the left and rise to the right for my end behavior. But let's say that this would be negative x squared, where it's an even power, but this time instead of having just an even power, we have a negative that's associated with it. Then we know we'd fall left and fall right in that situation. Another part of that one's pretty easy, the one part that we got today. And remember, this is not going to be on the test, so that's just a heads up for you, especially those of you who are not in class on Tuesday. That might be something you might want to look at going forward. Another thing to remember is that if I have something that's odd, an example of this would be x to the third. The relevance of 3 doesn't make, that's not the important part. The important part is the fact that this is positive and this is odd. We will rise right and fall left. Gianna, shout out to you. You did a phenomenal job of coming up with the fact that someone said, or she said, that if this is positive, think of like a positive line where it has a positive slope. And if it's negative x to the third, you remember the hand gesture I used, right? Where we kind of put our left hand up, right hand down, where we rise to the left and fall to the right. And what you would just say is rise left, fall right, and then whatever that end behavior would be in that situation. Okay? Awesome. I also told some students that number 25, I would do number 25 here. So let's take a look at that one. That's this one where it's x squared plus 2x minus 9. And again, I really apologize in advance on this one. I'm sorry, minus 3. This could be really rough, and so I apologize, but I'm going to do it for y'all the best I know how, okay? If you need some more help while I'm writing this, because I could tell jokes this whole time while I write this, but one thing that you could do is come in tomorrow morning. Feel free to do that, and we'll walk through some together. Or if you come in at 8:30 on Thursday, I'll be there available at that time as well for you going forward. I also think that you could check out the podcast from last year. That should be online. So if you need some help with that, you could check that out too. I think I put that on campus as well at the bottom of this page. So if you're watching this live, then you can go to on campus, and if not, then you can really look at the bottom of this sheet on the topics page here on campus. Okay, so on this one, 10 years later, I apologize. What we're trying to do is we're trying to say what on top multiplied by x squared gets me 2x to the fourth. Well, what we can do is we can actually simplify that by saying, well, that would be maybe like 2x squared, right? Because 2x squared times x squared is 2x to the fourth. So what we'll put is 2x squared right on the top. So we're going to put 2x squared here. Now, I don't just leave that there. Remember, now we've got to distribute to each of these 3. So 2x squared times x squared would be 2x to the fourth, okay? And 2x squared times 2x would be 4x to the third, positive, right? And then since we have 3, we also got to remember we got to do it to the third one, which would be negative 3 times 2x squared, which would be negative 6x squared. Now, this one we didn't have any values that we had to fill in, but let's say we didn't have an x squared. We need to be careful to put a 0x squared in place of that. Same thing holds true over here. If we have an x squared and a negative 3, be sure to put in a 0x between the two or whatever's missing. So now at this point, once I've distributed this, we can actually change the sign. So this would be negative. This value would be changed from positive to negative, and this would be positive here. Now notice once I do that, this cancels and this cancels, giving us a little cancel party. And what I'm left with is x squared right here. And this time I'm going to have to bring down the 3x. Okay, so bring down 3x right there. And we'll also bring down negative 2. Okay, because again, we have 3 on that outside over here. Okay, so bring down negative 2. So the question is what then times x squared gets me x squared? So we kind of answer the same question. In this example, we would get plus 1. Okay, I'll put it underneath the whole numbers. 1 times x squared is x squared. Put that in. 1 times 2x is 2x. Okay, hopefully you're following this there. Again, we brought down 2 because we have 3 values, so we've got to match it up to what's on the outside there. And finally, 1 times negative 3 is negative 3. We change the sign to a negative. This would be negative, and this would be a positive. So this would be x plus 1, and that would be my remainder. So I would put plus x plus 1 all over x squared plus 2x minus 3. X squared plus 2x minus 3. Okay? See, I got it? There we go. Perfect. Okay. Man, that was a journey. So that was how you would approach one where if it had 3, long division, really the ones that have 3 on it are the only ones that you have to really focus on in terms of long division there. Okay? Awesome. Let me check out. Oh, man, we have 7 viewers right now. I do have 7 viewers, so if for some reason, if you could do me a favor, text me any questions you have, and then also, would you mind, anyone that hears this, would you mind just texting me, telling me that you are confirmed that you can hear me, okay? Because this is a new Mac, and I want to make sure it's okay on there. Hopefully, this is somewhat legible for you. I'll do, again, like I said, I'll do the best I can on this as we go forward. While you do that, I will also go to listing the possible zeros. This is a really good one for the test tomorrow, and yeah, this will be a good one. So look at number 30. You'll see that it's x to the third, right? And I'll write this down, plus 3x squared minus 4, okay? Perfect. Awesome. Thank you all so much. I appreciate y'all saying that. And those that texted me, please, if you have any questions regarding any of these problems, let me know, okay? Perfect. Thank you all so much. I needed that. I just wanted to make sure everything was good. I know it's not the neatest right now. We had some technical difficulties, but if you've ever tried to do this by hand, it can be kind of tricky. So we'll do the best we can on this end. And if you can be patient with me, we'll do as many as we possibly can there as well. All right, Lawrence, thanks for saying that, dude. Okay, so while you all give me those questions, we're going to go over just listing possible zeros. This is number 30, but number 31 is, again, the same kind of one there. If we need to, we'll do that one as well. All right, awesome. And I love the fact that we have a ton of people here tonight. Thank you so much for showing up. It means the world to me, okay? All right, so one thing we want to do is when we list the possible zeros, we're always finding P over Q, okay? So what that means is we're going to list the factors of P over the factors of Q. Now, when you say factors, we're looking at the number P on. You can either say P over Q or you can say last over first, whatever floats your boat. But in this case, we're going to have 4 here. Remember, the negative doesn't matter in this case. So we're just going to put 4. Sorry, that's a 4. And then Q is going to be 1. Now, the beauty is with 1, the factors of 1 are just plus or minus 1. So whatever you get on top will end up being your answer, which is nice. If I had multiple answers, I would have to put each of the ones on top over the first value and then over the second value to get all of the possible factors there. Now, the factors of 4 should be 1, no particular order, 2, right, and 4. And all of them should have plus or minus. So really, since it's only 1 on the bottom, what we know of is the fact that this part right here is what's going to be the possible zeros. Remember that in the case of 30 and 31, those are just asking for the possible zeros. They're not asking for the zeros themselves on the test, right? The ones like 26 and 27 would be the ones where you actually have to solve for all of them. 30 and 31 would be more or less, hey, list the possible zeros. Now, I know it says find all the zeros. You could actually rep that out. That might not be a bad idea for this one, just because you will have a bonus or challenge question like that. So, for instance, if you put in, let's say, a value of 1 here, we could put the coefficients as 1, 3. Remember to put a 0 in for the x, right? So we're just going to rep this out. And again, you might say, Coach, why'd you choose 1? Well, it was in my possible zeros, and it just seemed like a good guess. So we'll see if I'm a good guesser or not. We'll bring down the 1 here. 1 times 1 is 1. 1 times 3 is 4. 4 times 1 is 4. 4 plus 0 is 4. 4 times 1 is 4. And if I'm going too quick on the synthetic, let me know. That's a big deal. You need to make sure you definitely know synthetic tomorrow. But since I got a remainder of 0, I actually guessed right. So to take this out, we're going to, since we start with x to the third, we're going to start with x squared here. So this is going to be x squared plus 4x plus 4. And you could probably have a good idea of what you're going to do now. You're going to factor, or you could do the quadratic, but here you could actually factor. Two numbers multiplied get me 4, but added equal 4. Well, it'd be 2 and 2, right? You could do x plus 2 and x plus 2. And once I kind of do that at that spot, I can set them equal to 0. And this would be -2. And you don't need to list it twice. You could if you want to. But the zeros would be 1 and -2. The multiplicity of 1 would be 1. But the multiplicity of -2 would be 2 because it's repeated once and then twice. And remember, if it has an odd multiplicity, it goes through. An even multiplicity will end up bouncing on that side. Okay, man, that's some good stuff. That's a good question. I haven't gotten any questions yet from y'all, which means that I'm hoping you're all good. Again, if someone ends up putting it in the group message for some reason, I can't see that on the group message when you watch it live. So if you want to, you could feel free to let me know, and I'll get it going there. Okay. All right. Okay, so let's go to, I'm just kind of skipping around here, y'all. I did want to get one of these on here just so that we have it. Okay, so I'm going to make this up. No, you don't always have to state multiplicity on the possible zeros. I just did that just because. That's a great question, Maddie. Now, as far as like 21 goes, that one we will have to do, right? Because if we start with x to the third, and I think I did this one in class, but minus 8x squared, sorry y'all, plus 16x, and I know that that's equal to f of x or c of x here, but you get the idea. We could factor this out by taking out an x value, right? Leaving us with x squared minus 8x, right, plus 16. So what we can then do is then say, okay, what can I do to factor this inside part? What are two numbers when multiplied get me 16, but when added get me -8? Well, in that situation there, you would say x minus 4 and x minus 4. And you would put those two in there because they multiply to 16, but had to be equal to -8. So my zeros would be 0 and 4. Just so I don't have to write it out, I'll put it here. The multiplicity of 0 is 1, no exponent, right? And the multiplicity of 4, since there's 1 here and 1 here, is actually 2. Okay, so that's what the green is. On the test, you'd actually say 4 has a multiplicity of 2, or 0 has a multiplicity of 1. And since it has a multiplicity of 1 here, it's going to go through the x-axis. And because this is multiplicity of 2, because it's even, it will bounce on the x-axis. Okay, good questions there. 21. Oh, good question. Okay, so 21, the question that I just got was, is 21 end behavior rise right and fall left? You are completely right. Good job. That was good work right there. Remember that because this is odd, correct? And because this is positive on the outside, you could think of putting your right arm up and your left arm down, correct? Where I rise to the right and fall to the left. And that's how I would have the in behavior there. Okay, rise right and fall left. Okay? Awesome, awesome, awesome. Very good questions. These are good ones here. 5 and 9. Let's see here. Yeah, 9's a good one. Okay, let's do number 9. Let's go there. Okay, so number 9 says 2 minus negative square root of -9. Now, if you can't see this, this might be something I might need to explain, but that negative inside of a square root always comes out as an I. So you really right now, this is the same thing, if that makes sense, where it's now 5 plus I squared root of 25 there. And we'll kind of go from there. Now, before we end up multiplying this, we can then go to the square root of 9 and make that 3. Now, on the one that's on number 10, you would simply just simplify the radical. But since this is a perfect square, this kind of works out a little more beautifully than number 10. both of these do, to where you would have 2 minus 3i, because the square root of 9 is 3. And for the second one, I would have 5 plus 5i, okay? And again, square root of 25 is 5 there. So we then distribute 2 times 5 being 10. 2 times 5i gives me 10i. Negative 3i times 5 is negative 15i. And negative 3i times 5i would be negative 15i squared. Okay? So that's, again, what we would take when we distribute. Now, what we could combine like terms. Remember, I squared is negative 1. Just a side note, if you ever get something that's I to the third, that would be 3 i's, right? This is not, by the way. I just want to make sure I went through this. And this would produce a negative 1. Negative 1 times I is actually negative I. So if you need to write it out, you might have to do that. But this is negative, so this would be 15. 15 plus 10 is 25. 10i minus 15i is negative 5i. So what we would have then is 25 minus 5i as my answer for number 9. Okay. Now number 5, I think, is what was said there. We can look at number 5 here. By the way, just a heads up, wanted to say thank you so much to the chapel group. If you were involved in that, oh my gosh, today, that was absolutely incredible. Just blessed me. So thank you all so much. I know y'all worked really hard at that. I'm glad we were able to experience that. Y'all did a great job of leading us and reflecting on Easter and that sort of thing. So great work there. On number 5, we want to hit this one. This was one that was asked here. One thing to remember is the I on the bottom is kind of like a square root, where we just don't want it there. So in this case, we want to distribute by the conjugate of this, which would be 3 minus 5i. So we're going to multiply there on the bottom and on the top. Now, if you do this, I swear I'm going to haunt you. I will come and haunt your goldfish, okay? This does not cancel. Please do not cancel that. Please don't do that, okay? Don't. In this, what this refers to is we still distribute. 3 times 3 gives me 9. 3 times negative 5i is negative 15i. Sorry, I know that's messed up. 5i times 3 is positive 15i. And 5i times negative 5i is negative 25i squared. Okay? Now remember, I squared produces, that's gone, right? Like a freight train. It produces a negative 1, to where this would then be positive 25. Now on the top, we would distribute 15 times 3 to get 45. And 15 times negative 5i to get negative 75i on top. So we have 45 minus 75i on the top side. These i's cancel because we have negative and a positive 15i. And 9 plus 25 is 34. So what we would be left with is 45 minus 75i all over 34. You could also write this as 45 over 34 minus 75 over 34i. You could kind of break it up to where 34 goes with the left one and the right one, or you could keep it like this. This one you can't reduce on this one, so it's not as big of a deal, but ones where you need to reduce might be one where you kind of put it in under both there. Okay, awesome. Okay, so do I see any other ones? Do y'all have any other ones that you see that we need to kind of address on that? Trying to see if we got on the front page. Just be sure on number 3. Just a heads up, we kind of already did a when we distribute type of thing. We've already done that one. If we have negative 3 plus 4i squared, don't just put the squared to both of them and say, oh, that's 9, plus 16i squared. No, no, no. That means we're going to have to put 2 of them, right? So negative 3 plus 4i, not times negative 3 plus 4i. So just be sure you would distribute just like we did above here when we did 3 plus 5i times 3 minus 5i. Except this time we're going to just keep it the same if it's squared. Okay? Same thing holds true on 2, 3, and 4. On number 1, also, because the negative signs between Okay, so what I'm saying is this one. This is number 1. On this one, since the negative's between, we're not going to distribute. Oh, I'm sorry, I know I'm running the other one, but hopefully this will make sense here. I'm just going to talk through it. We're going to distribute -2 to each of these, right? Because it's piggybacked next to each other. But once I do that, then at that point, we drop the parentheses and we just combine. Because the negative's in the middle, we don't distribute this side to this side. No, no, no. What we need to do is be able to distribute that -2 first and then just add like terms. But when it's piggyback like this, right here, or squared, that's the time that we want to focus on distributing both of those factors there. Okay? Okay. Yes. One thing to really quickly, it's P over Q, right? I think I have that one. Where are you? Yeah, remember P over Q, and this right here is the last. It's the last over the first, right? P over Q. Now, I think I've seen people actually do it opposite. I'm not going to confuse you. Just remember it's the last number over the first number. That's the big thing. 4 factors of 4 over 1. Okay? Hopefully that helped you there. Yeah, let's do number 12. I just saw number 12 there. 2x squared minus 3x plus 5. It's a good one here. Okay, so remember the quadratic formula is really there's 3 formulas that you'll need. You'll need this one. You'll need the quadratic. Sorry, I'm trying to. Wow, that's awesome, right? It's great handwriting. Quadratic formula, and then the third one would be the negative b over 2a, which again is the vertex for standard form, right? So if I had like x squared plus 2x minus 1. Remember on that one, this is to find the vertex, we would have to use negative b over 2a. Whereas if I had one like this, we call this vertex form, by the way, what I'm about ready to do. X plus 1 squared minus 1. In this one, it's a lot easier. You don't have to do negative b over 2a because the vertex would be the transformation. So it would go left 1 and down 1. So just a heads up on that in case you needed it there. So, but coming back to the one you had, Lawrence, we have 2x squared minus 3x plus 5. And what it asks for is it asks for the x-intercepts, okay? Or it says use the quadratic formula to solve. It's kind of the same thing because 0 right now is plugged in for y, right? Okay. So now what we have is the quadratic formula, which would be x equals negative b. Well, b is already negative 3, so we'll just say positive 3 plus or minus the square root. And it's b squared, so b squared is negative 3 squared, which is 9, okay? Minus 4, and a times c would be 5 times 2, which would be 10, okay? All right, that's a times c. And then all over 2a. One thing to remember is when you plug in negative 3 squared to get 9 in your calculator, if you plug this in your calculator, you'll get it wrong because it'll come out as negative 9. Be sure to put in parentheses, or you could just do it in your head. It's either way. But then it's all over 2a. Well, a is 2, so 2 times 2 would be 4. Lawrence, if you could just confirm with me, does that make sense with what we were saying there? I'm hoping that makes sense with what we were talking about. But the idea on this is once we simplify, we get 3 plus or minus the square root. And this would be 9 minus 40. So 9 minus 40 would be negative 31. Okay. All right. Okay, so how did are you, just a heads up, I just got a text here. Let me hold up for a second. So this is x equals negative b. B is negative 3, right? So be negative 3. That's how I got 3. Plus or minus the square root of b squared. So negative 3 squared being 9. That's how I got this here. Minus 4 times a times c, or 2 times 5, which produces 10. And then all over 2a. All right, Lawrence, does that help? 2 times 2, that's how I get that 4 there. So then I say 9 minus, this is 40 right here, right? 9 minus 40 plugged in or just doing mentally would be negative 31. Okay, let me backtrack. And perfect. And then this is all over 4. Now, to kind of simplify this, we know this negative on the inside, we're going to make it to a positive, and instead we're going to put an I on the outside. So it should be, the 4 will go into both parts. So 3 over 4, okay, 3 over 4, plus or minus I root 31 all over 4. So we want that 4 to actually be applied to both parts there. And that's really my right answer. Now, if there was like a number in front of I that I could reduce by 4, if this 3 could, then you could reduce that on each fraction based upon what goes into 4 in that way there. Okay. Awesome. Okay. Okay. Next one, number 19. Oh man, y'all are stretching me. Y'all are stretching me. Okay. I will definitely do this one. This one's a good one. Let me do the middle one because I think I did a lot of the third one in classes today. But if you need another one, feel free to come by tomorrow. We can take a look at that, okay? So as far as graphing this is concerned, we'll try to do the best we can on this side. This is going to look absolutely awful. It's good. People are going to watch this video and think, what is up with Coach? But we'll do, like I said, we're doing the best we can. We're dominating the best we know how. So we have y equals x squared minus 4x minus 1. And there we go. Now, I told you that in the instance where you have a standard form, right? And if you're looking for vertex form is the one that's right above this, x plus 2 squared minus 2. That one's one where vertex is easier. But with this one, vertex is a little tougher because we have to do our equation to find the vertex because of standard form. So what we would have is negative b over 2a. So what would be b in this example? Well, b would be negative 4. So we have minus negative 4 all over 2 times 1, because that's a, right? A is 1. So this would be 4 on top divided by 2 equals 2. Okay, so we have 2 in for our first part, okay? And to get what the y is, we're going to plug 2 back in for x. Okay, so we're going to have 2 squared minus 4 times 2 minus 1. So we're trying to get what the y is on that vertex. So I always do the squared first. So we have 4. Then I do multiplication. Minus 8 minus 1. So this actually does a little bit easier for us where it kind of comes out even here. And this would be negative 5. So we would have our vertex would be 2 comma negative 5. So we could put it up there somewhere as close as we can. Put it here. 1, 2, 3, 4, 5. Now the question is that 2 I'm sorry, that's 2, 5. I'm sorry. 1, 2, 3, 4, 5. And I'm going to erase this. At 2, negative 5, that's the vertex. Is this thing going to go up or down? Well, we can assume it's going up because of the fact that this is positive. Think of end behavior, right? So since it's going up, we're going to go up at this spot. So this right here would be a minimum. I think that's another question kind of on the test there. Hold on just a second. This is all messing up. Okay, so this would be a minimum on this side. Okay, so we got that there. So to find the next one, we're going to find the y-intercept. And to find the y-intercept, we plug 0 in for x. Okay, so this would produce a 0 squared, which is 0, minus 4 times 0, which, again, this is 0. So 0 plus 0 minus 1. 0 plus 0 minus 1 would be negative 1. So my y-intercept would be 0, comma, negative 1. Okay, so that would be what my y-intercept would be for that example here. So 0, negative 1 is here. Now to graph it, we don't necessarily need the x-intercept. I'll do that in a different color here in a second. But so what we'll do is we'll say, okay, this goes up. We know it's going upward, right? It's going up here. So we know it goes up 1, 2, 3, 4, and then over to the left 2. So it's going to go up 4 and then right 2. Okay. So we go here and go just like so. Okay. So that right there, that's the quadratic. Now let's do the x-intercept just to get another rep in. And this actually might skip this one just because of the fact of room, and we already did this, but we would plug 0 in for y. I will talk through it though. And if I need to, if you put this down here and you need me to do another rep of the quadratic, please let me know. Okay. All right. So once I get to this point, I could do the, I could try to factor, but there's no numbers when multiplied get me -1 and when added equal -4. So that's why we're going to do x equals -b, which is 4. I'll do it quickly. Plus or minus the square root of b squared, which is 16, because -4 squared 16, minus 4. A times c is -1. And then all over 2a. A is 2, so we'll put 2 here. Simplifying this on the inside, you get -4 times -1 is 4. This would be 20. So what you would say is 4. Wow. Okay, 4 plus or minus 2. We could take out of that square root 2 root 5 all over 2. And then you could do definitely that to get what the x-intercept is. You could also put a decimal in this example, especially because we could use it to graph. So either of those two would be good by me. Okay. All right. All right. We're going to wrap this up here. We'll kind of do one more on this. Or I say that if you have any other questions, come on. Yeah, Ashley, I see 26 or 27. That's actually a really good one. Let's take a look at 27. Or actually, doesn't matter. We could do 26. Let's do 26. So first of all, it says that 2 is a 0. So let's put 2 in for the box. And the numbers that are next to it are going to be from the highest degree down. So 2, -5, 1, and 2. So we're going to do synthetic here. And again, 2 is given, so we can assume that the remainder should be 0. Unless I messed up or something happened. So we're going to bring down 2 first. We then multiply 2 and 2 to make 4. We add -5 and 4 to get -1. We then multiply 2 times -1 to get -2. We add to get -1. And we multiply 2 times -1 to get -2. So what we have now is on the bottom, we've got 2x squared minus x minus 1. And what we just proved was that 2 is actually a 0. So now what we want to do is we want to factor this out by plugging 2x in for both. Now, I'm doing the a times c method. However, if you want to do check and guess, that's fine. I kind of done it both ways, but either way works. So a times c, we put, again, a in for both. A times c is -2. So because of that, we say, what two numbers when multiply get me -2, but when added equal -1? Well, I think there's only one there, and it would be -2 and +1. So we'll put -2 in for one and +1 for the other. What can we factor out of 2x minus 2? Well, we could take out a 2 here, leaving us with x minus 1 right here. And here we can't take anything out, so we're left with 2x plus 1. So that's factored out the rest of it. And so to find the other zeros, we have a 2 up here. If I set this equal to 0, I would get 1. And if I set this equal to 0, we might want to put this over to the side. We're going to subtract 1 first on here. Subtract 1. We get 2x equals -1. Divide by 2, divide by 2. X is equal then to -1/2. So we have 2, -1/2, and 1, all with a multiplicity of 1. I don't have to say it here, but just so you know. And if it has an odd multiplicity, that means it's going to go through. Okay, go through. Okay, deep breath. That was very tiring. With my hand here, gotta love it. This is good for me. Builds character. Someone asked, aren't there some circumstances where you have to put the same 0 twice because the multiplicity is more than 1? I think number 30 is like that. Very possible. There's a possibility where, like on number 30, you could possibly have to use it twice, like where the 0 of 2 could be done twice. Remember that a lot of times with the ones on the test, I'm going to give you that first 0, and then it'll be to a point where after you do synthetic, you can factor. That's there. Please do not apologize for the question amount. Man, anybody that has questions, man, I'm all in for. I appreciate y'all for showing up, and good night. That's what I'm here for. I hope y'all care about y'all a lot. I really do want y'all to be successful. So that's why I'm here, trying to get those questions answered. So please, if you got more questions, go right ahead. What I'll do is I'll wait for another 30 seconds here. And if you have more questions, come on. If you don't, what we can do is tomorrow we can hit on a couple of the other ones that maybe you struggled with, or some ones that maybe we need to go over again. Feel free to check out the podcasts that are below, because I think there's another one down there. This is the most up-to-date one, so I can't promise that the one from last year is identical, but it'll have a lot of the same stuff, if not all of the same stuff that's there. Okay, awesome. Okay, let's do this. Oh, you want a shout out? Maddie, little shout out to Maddie right there. All those people from Sweden. There you go, right there. Maddie, by the way, is committed to a Swedish school. So just so everyone knows, she just had told me that the other day. So for those Swedish students out there, heads up, Maddie there. And I have a lot of other people that I could give shout outs to. I try not to give shout outs just in case people don't want shout outs. So if I don't use your name, it's not because I don't have it, because I have it here. But a lot of times, Savannah and mom. Oh, shout out to Savannah and Savannah's mom. Look at that. Hope y'all are doing well. Thank y'all for putting up with my craziness and trying to get through this today. I know this was a little slower, but we got through it. Hallelujah. Praise Jesus. So again, study sessions, just again, a heads up before I close out today. The study sessions will end up being twofold. You could come tomorrow if you want to tomorrow, and we will kind of go over that. Tomorrow morning is a really big one, but Thursday you could also do from 8:30 to 9. I know it's a small window, but I got a little meeting on Thursday, and we will open up with a couple questions in class. All right. I do want to give you time to work on the test, so it won't be too long, but just want to make sure I give a heads up there. Anyway, hope you all are doing well. Great job. I love the focus. Man, especially seniors. I think at least in my Algebra 3 classes, I've really sensed some focus. It's been really good this week. So keep it up. Excited about the test to get it here and get it done. And proud of y'all. Love y'all a lot. We will see y'all tomorrow. Shout out in the hood. Bye.